Hey guys, welcome back to another episode of Absolute Astronomy, the podcast where we discuss space things because space is cool, so let's talk about it. First, want to apologize if I sound really nasally, because I know I did in the YouTube video I just put out, but it is April, and that means allergy season, and before I started recording this, I actually had a solid 5-minute sneezing fit, so let's hope I can make it through the podcast without sneezing. So we've come to the end of our in-depth look at our solar system, and today we're going to be talking about the little guys. But before we get to that, let's start things off with a twist.
3, 2, 1.
Welcome to This Week in Space Talk, where we discuss what's making headlines in the space community. Stephen Hawking has backed an ambitious $100 million project to send a probe to a nearby star. He, along with a group of scientists and billionaire Yuri Milner, unveiled the plan last Tuesday titled Breakthrough Starshot, which aims to build a tiny light-propelled robotic spacecraft that could visit the nearby star Alpha Centauri. Such a spacecraft could be accelerated up to 20% the speed of light and could reach the star within just 20 years. Presently, it would take a conventionally propelled probe 30,000 years to reach the star, which is 4.37 light-years away. The Starshot spacecraft will consist of a wafer-sized chip attached to a super-thin sail. It'll be launched to space from a mothership and then propelled to the stars by laser light beam from high-altitude facilities here on Earth. If successful, the spacecraft would capture images of other possible planets and scientific data and send it back home in a beam of light. Hawking says that with light beams, light sails, and the lightest spacecraft ever built, they can launch a mission to Alpha Centauri within a generation. He said, quote, "Today we commit to this next great leap into the cosmos, because we are human and our nature is to fly." Coming up, we'll be discussing the little guys hanging out on the edge of our solar system, but first, here's some Panama Wedding on Absolute Astronomy.
It's more than I could take, just slowly coming down. Spinning figure eights, but I'm in it, and I'm barely half awake, just waiting on the ground for the hourglass to break any minute. We're living an American life, keeping busy, wasting time. We're running on a chemical high, and it never felt so good. Living an American life, keeping busy, wasting time. We're running on a chemical high, and it never felt so good. We're infinite high, we're infinite falling, infinite high, and it never felt so good. We're infinite high, we're infinite falling, infinite high, and we never had it so good. Infinite high, infinite high, infinite high, infinite high, infinite high, infinite high. Life is getting hard, living month to month on a credit card, and it's never quite enough just being who we are. We're searching for a rush until we've gone too far. Living an American life, keeping busy, wasting time. We're running on a chemical high, and it never felt so good. Living an American life, keeping busy, wasting time. We're running on a chemical high, and it never felt so good. We're infinite high, we're infinite falling, infinite high, and it never felt so good. We're infinite high, we're infinite falling, infinite high, and we never had it so good. Infinite high, infinite falling, infinite high, and it never felt so good. We're infinite high.
Welcome back. That was the Bee's Knees remix of Infinite High by Panama Wedding. And no, I didn't use the term Bee's Knees to describe the remix, that's actually what it's called. Pluto, Ceres, Haumea, Makemake, Ares. Recognize any of these guys? They're small but mighty, and today we're going in depth about the dwarf planets. Dwarf planets are a lot like regular planets. They both have enough mass and gravity to be nearly round in appearance, and they both travel through space in a path around the sun. The only difference between a regular planet and a dwarf planet is the area surrounding each celestial body. A dwarf planet doesn't have a clear path around its orbit, while a regular planet does. Dwarf planets' paths around the sun are usually filled with asteroids and comets. Basically, if you're small and you got a bunch of other little objects hanging around you, you're a dwarf planet. There may be dozens of dwarf planets drifting around in our solar system, but so far we've only identified a couple. Closest to home we have Ceres, which is located in the asteroid belt between Jupiter and Mars. It's named after the goddess of corn and harvest and was the first dwarf planet to be visited by a spacecraft, which was the NASA Dawn mission. Ceres was first discovered in 1801 by Sicilian astronomer Father Giuseppe Piazzi. It's going to be a lot of funky names going on in this episode. Over time, similar objects were found in the same region, and Ceres went from being classified as a planet to being labeled as just an asteroid. But in recognition of its planet-like qualities, Ceres was designated to a dwarf planet in 2006 along with Pluto and Ares. Gravitational perturbations from Jupiter billions of years ago prevented it from becoming an actual planet. In astronomy, perturbation is the complex motion of a massive body subject to forces other than gravitational attraction of a single other massive body. Other forces can include a third body, resistance, and the off-center attraction of an oblate or otherwise misshapen body. Basically, Ceres would have become a full-fledged planet if it weren't for its surroundings. Ceres looks a lot like our moon, and it actually has a lot in common with us. There are signs that Ceres contains large amounts of water ice beneath its surface. Scientists found evidence for water vapor which might have been produced by cryovolcanoes or through sublimation. Astronomers estimate that if Ceres was composed of 25% water, it may have more water than all of the fresh water we have here on Earth. Up next, we've got Ares, an icy planetary body which takes 557 years to complete a single rotation around the sun. Ares has a rather peculiar orbit plane because it doesn't have a perfect circular orbit like most of the major planets in our solar system do. It extends far beyond the Kuiper belt on an angle, and it's kind of hard to describe without being able to see it, so feel free to head on over to the Google machine and see what I'm talking about. Ares is often so far from the sun that its atmosphere actually collapses and freezes on its surface in an icy glaze. Scientists believe that the surface temperatures range from -217 to -243 degrees Celsius. The thin atmosphere will thaw in hundreds of years as it gets closer to the sun, revealing a rocky surface which scientists believe is similar to Pluto. Speaking of that, Ares first appeared to be larger than Pluto, which triggered an infamous debate in the scientific community. Recent observations indicate that Ares might actually be smaller than Pluto, but now they're both considered dwarf planets, so it doesn't really matter anyways. It's kind of ironic because Ares is named after the Greek goddess of discord and strife, which is fitting since it remains at the center of the debate about the definition of a planet. Now we're going to be talking about Haumea and Makemake. Both nestled in the Kuiper belt, these two babies are the most recent dwarf planets to be discovered. Haumea was discovered in 2003 and named after the Hawaiian goddess of childbirth and fertility. Makemake was discovered in 2005 and named after the god of fertility in Rapa Nui mythology. Lots of, fertility themes going on here. Haumea is one of the fastest rotating objects in our solar system. It completes a turn on its axis every 4 hours. It's possible that a massive impact billions of years ago set off its crazy spin and created its two moons, Hayaka and Namaka. Astronomers have found signs of frozen nitrogen, ethane, and methane on Makemake's surface. They also found evidence of tholins, molecules that form whenever solar ultraviolet light interacts with such chemicals. However, tholins usually cause a reddish-brown color, but Makemake doesn't appear this way, so there must be some component that we're not aware of on the planet. And finally, we've come to Pluto, the most famous dwarf planet of them all. The king of the Kuiper belt was discovered in 1930, and it was named by an 11-year-old girl who suggested the new discovery be named after the Roman god of the underworld. Pluto's 248-year-long elliptical orbit can take it as far as 49.3 astronomical units away from the sun. Like Ares, its orbit isn't a perfect circle, and again, head on over to the Google machine to check out what I'm talking about. From 1979 to 1999, Pluto was actually closer to the sun than Neptune was, despite it normally being outside of Neptune's orbit. In 1989, Pluto came within 29.8 astronomical units of the sun, providing us the rare opportunity to study the planet at a closer range. Also like Ares, whenever Pluto draws near the sun, its surface ice sublimates and creates a temporarily thin atmosphere. Pluto's low gravity causes the atmosphere to be much more extended in altitude than Earth's atmosphere. Pluto becomes much colder during the part of its orbit when it's traveling away from the sun, resulting in the atmosphere freezing and returning to the surface as snow. Pluto has a very large moon that's almost half its size named Charon. Some people pronounce it as Charon, and both ways are technically correct. The moon is so big that Pluto and Charon are sometimes referred to as a double dwarf planet system. Because the two are so small and so far away, they're extremely difficult to observe from Earth. There was even a period in the 80s where Pluto and Charon passed in front of each other repeatedly for several years. Even planets enjoy messing with us from time to time. And unless you were living under a rock last year, on July 13th, 2015, a picture was taken of the planet from NASA's New Horizons mission. It went viral because this was the first time a spacecraft has ever actually visited the planet and been able to get a detailed look at it. It even has a heart-shaped feature on its surface. Even from far, far away, Pluto still managed to send us some love. Welcome back. That was Slow Burn by Autograf. And unfortunately, we've come to the end of yet another episode. Thank you guys so much for tuning in. Be sure to follow me on Twitter at Astro_podcast and also check out the YouTube channel. And as always, if you have a topic you'd like me to discuss, feel free to send me a message. Adios.